Here we have the single bond throughout, which is N, and then we have the OH, which is for alkanol, and then we have the halogens, that's for the haloalkane.
Guys, Sama just took away my fear I had in chemistry and biology. You have to join the easy ones. My name is Victor Modia, a student in Italy. Anywhere you are, you can join us. Join the easy one. Be a subscriber. Bye. Thank me later. Whenever you reach for me.
We're going to be using this ball and stick model to teach you how to name alkanes, an organic compound. And you see the structure here, very complicated. I'm going to be teaching you how you can name this and simplify this thing as it looks complicated. Remember, I will also show you what these colors means and each of this ball, what they mean. So thanks for watching and enjoy more and more. Subscribe if you have not subscribed. If you have subscribed, thank you. Don't forget to share this my video. I cannot do without. I'm going to be using this ball and stick model to teach you how to name organic compounds, basically the alkanes and other simple molecules. If you're finding it difficult in the nomenclature, I had a video, a live stream here on how I taught you how to name organic compounds. But today I want to use this to demonstrate this for you. I assure you this will make it easier for you to understand. So this is called ball and stick model. These balls have different colors and different sizes with different holes, and they represent different things. Here are the sticks, of course. That's why I call it the stick. The ball, here are the balls. So they have different colors. So we will start by telling you what these colors mean. For example, the first, this smallest one is hydrogen. This white one, it already has the bond attached to it. The stick is the bond. Then this green is chlorine. Green is chlorine, and remember it has only one hole, which means it can only accept one electron to attain octet stability. Now the other colors we have here, we have, as far as organic chemistry is concerned, we cannot do without this particular powerful one. This black is actually carbon. Carbon is tetravalent. If this is well organized, it's going to have 4 holes. It's supposed to have 4 holes. Okay, this is complete. Over here is 3, 1, 2, 3, and then 4. So carbon is black. Get them by color. Then the other ones we need to know, as far as organic chemistry is concerned, is red is oxygen. Red over here is oxygen. Red is oxygen. And other color identification, then we have yellow here. Yellow is sulfur. This is sulfur, the atom of sulfur, and it also has 2 holes. Remember, it has the configuration of 2,6, which means it requires 2 to attain octet configuration or rare gas configuration. Other colors that are not here, you can, blue represents nitrogen actually, purple is for iodine, then gray or silver colors should be metal, but they are not here. Now we want to demonstrate the most simplest hydrocarbon in this case. Okay, here is carbon. Here are the hydrogen atoms. This will also help you in understanding shapes of molecule and the angles. Yeah, this is methane. That's CH4, methane. So when you see them, they draw this. That is exactly, if I want to represent this, then okay. So this now, if I want to draw it, to represent it, we have this. This is C. Then here, hydrogen, hydrogen, hydrogen on a flat surface. But this is the normal orientation. And by naming, since there is only one carbon, which is met, we call it methane because there is only one carbon. So now you have seen the basics. What I'll be doing next is that in organic compounds, we might not waste time fixing the hydrogen again. because nomenclature lies mainly on the carbon itself. So it means that if I should remove one of the hydrogen and then fix this green, remember in the beginning I told you that green is chlorine. What it means is that I've replaced one hydrogen here with a chlorine atom, and this means Cl, so that this molecule here is chloromethane, one chlorine and one methane. So if I substitute the whole hydrogen with chlorine, it becomes automatically tetrachloromethane. If I substitute 3 and leave 1 only, it becomes trichloromethane, known as chloroform. So you see the ball and stick model. Now let's advance a bit. I won't be using hydrogen again this time. Let me use only the stick and then the ball as far as carbon is concerned. So in this compound we only have 2 carbons. Remember, the empty holes represent nothing but just hydrogen. So this is methane, ethane, because 1, 2, neglecting the hydrogen atoms. So if I fix more of this here, so this thing you are seeing here is nothing but carbon 1, 2, 3. This is the longest chain and the only carbon there. So remember, I will be fixing hydrogen on each hole, but it will waste more time. So it means that if you are to draw this, often if you see this, they will draw it this way. Simple. That is this. Each edge is carbon. This edge, nothing is attached. So how many carbons are here? 1, 2, and 3. But you won't be, these circles will not come there. So if you just see something like this one means 1, 2, 3, 4. So if I will add more for this type of molecule, that's 1, 2, 3, 4. That's boot. But in the case, that is exactly what is here, 1, 2, 3, 4. So it's a way of writing the structure in a condensed way and also to save time. Okay, so the name of this compound is 1, 2, 3, 4, and a single carbon to carbon bond throughout, and 4 is boot. Therefore this structure I'm having here is butane. So it's as good as drawing it even in a straight way, 2, 3, then 4. Remember, hydrogens are there, so it does not determine. But unfortunately, the orientation is not in a straight way, in real sense, when you study the structure of the molecule, and hence, because of the 4, you say boot. And because of the single bond throughout, you say ANE. So this is butane. Now, we are going to advance a bit in a structure that might be more complicated than just being a straight chain. This will help you to know when there is branch and when there is no branch, because on paper the drawing might be very far from the reality, but here I'm bringing a closer model. Okay, over here, if you are told to name this molecule, it might look a bit complicated, but what you have to do here is just start from primary carbon, and this is very correct for you to learn what primary carbon is. This is very, very okay. Now, where do you start counting? Start from a primary carbon, which means I'll use this opportunity to teach you primary carbon, secondary carbons, primary carbon, secondary carbon, we have the tertiary, and then we have the quaternary carbon. Quaternary carbon. Okay. Watch. Primary carbon is carbon that is attached only to one carbon. Watch this. This carbon is primary. Why? Because it's only attached direct to one carbon. But this carbon here I'm holding is tertiary because it's attached to 1, 2, 3 carbons. So in counting the longest continuous carbon chain, you start from a primary carbon and not secondary, not tertiary, not quaternary. So here we have primary carbon. Here is a primary carbon. Here is a primary carbon, this one here, but this is tertiary because it's attached to 1, 2, 3. But carbon here is also, this one is also tertiary, 1, 2, 3. But this one is primary carbon. So we have about 4 primary carbons here, which are 1, 2, 3, and 4. So in counting, you start from the primary carbon. So I might start like this, 1, 2, 3. Remember they say longest continuous carbon chain, or I'll take 1, 2, 3, 4, which is correct. 1, 2, 3, 4. Just start from a primary carbon and end in another primary carbon. Don't just end in the middle or start here. If you start here, you started in the middle of the chain. So 1, 2, 3, 4. From all angle, I got 4, which means the root is still boot. And then the carbon I did not count in that main chain is now branch chain. Therefore, I counted 1, 2, 3, 4. It means that this 1 and this 2 are branches. This is branch chain hydrocarbon according to my counting. But if I counted 1, 2, 3, 4, 1, 2, 3, 4, it means that this 1 and 2 are my branches. Will I get a different name? No, I will get the same exact name. So in that case, I've gotten my boot. Why? 1, 2, 3, 4 as the longest continuous carbon chain. Then I'll start numbering the carbon from the end. Since it's alkane, you number from the end. That gives you the lowest possible number. I'm going to number this carbon in this main chain to know the positions of these branches, to tell the person where these branches occur. So I'll call here carbon 1, 2, 3, and 4. If I use this pattern, you find out that it is at carbon number 2, there is a branch, and that branch dropped 1 carbon, and 1 carbon still remain met. 2 carbon means earth, 3 carbons means prop, 4 carbons means boot, and hence I wrote this boot here. But when it occurs as a branch, I'll just be putting YL, butyl, ethyl, propyl. So in each of these, met, earth, prop, boot, pent, hex, hept, octanon, dec, on dec, which means I'll now say carbon 1, 2. So at carbon number 2, there is a methyl. So I have 2 methyl. Then I go to carbon number 3, I also have 3 methyl. So I have 2 methyl, meaning that at carbon number 2 there is a methyl branch, not that there are 2 methyl groups, no. Then at carbon number 3 there is still what? A methyl group. So we have 2 methyl, 3 methyl. Because of the fact that they are all methyl methyl, I will factorize and join them together by saying 2, 3 dimethyl, because they are all methyl methyl. So this should now be 2, 3 dimethyl butane. I will put ANE, and that's the name of this structure. Why? Because there are single carbon to carbon bond throughout. Okay, so let me add more carbon to this, trying to make it more complicated but simple for those that know the rules. It will never be complicated beyond nomenclature. Okay, we'll still join them. I know you are really enjoying this. Why not subscribe and share? Thank you. Continue enjoying. Okay, we are going to be naming this structure over here. It looks complicated, and remember the symbols of the atom. Black is carbon, of course, hydrogen is white, and green is for chlorine, also fluorine. Oxygen is red over here. So this structure, I can draw it in a way that we will understand it more here. As I keep it down here, I can start drawing it. But before then, even without drawing it, you can name it as it is. This way, you count from the primary carbon and start in a primary carbon and end in a primary carbon. So over here is a primary carbon. Why? Because it's attached to only 1 carbon direct. Remember, this is chlorine, so this is not secondary. Don't get it confused. So I can start counting here 1, 2, but I can't start here because this is a secondary carbon, tertiary carbon, either this one, because it's attached to 1, 2, 3 carbons. So I'm only allowed to start here, here, or here, because these are the 3 primary carbons in this molecule. So I'll count 1, 2, 3, 4, and 5. So the longest continuous carbon chain here is 5. And then, but the total carbon should be 6, but this one was not counted, so it's a branch. And therefore, you see this oxygen here is also attached to this last carbon, or the first carbon, either. So now, first of all, let's draw this so that you catch up with what I'm saying. So I'm going to start with this carbon here. and then I've covered this 1, 2, 3 carbon. Remember, each ending is carbon. Then I'm extending to this carbon, so I've gotten number 4. Then I come back to this carbon. So we have 5 carbon, 1, 2, 3, 4, 5. Then I'll begin to attach any other thing. So at carbon number, this particular last carbon here, that's where I have my, this is oxygen, this is oxygen, this is hydrogen, this is OH. Therefore, I will attach OH here. Then this is the second. Remember, this point is the first carbon because I've written OH here. It is not, you don't count it as carbon again. So this is the first carbon, second carbon, and in second carbon I have this chlorine. So what I'll do is just to attach my Cl. Then I extend to carbon number 3. There is nothing except hydrogen throughout, so no substance group. Then carbon 4 here, remember, I have another carbon. This is CH1, 2, 3. So this is CH3, of which I will attach here CH3. Then this last one also have chlorine, so I will attach my chlorine. I have drawn this structure. Then to make it easier for you to understand more and more, I can also draw it this way: 1, 2, 3, 4, and 5. Then I will attach this OH here. That is this OH. Then these two hydrogens will be like this. Then at carbon number 2 here, I will attach my chlorine, and then extra 1 hydrogen, because it is now 1, 2, 3, 4. Remember, each carbon will be surrounded by 4 bonds. Therefore, that is 1 hydrogen. I extend to this carbon number 3, which is here. There is no other thing that is attached to it except 2 hydrogen atoms. As you can see, 2 white balls. Then here, I have to attach this CH3, which is over here. I might write it there to save time. Then another hydrogen, that's this hydrogen over here. Then coming to this carbon, I will attach this hydrogen. There's another hydrogen that's supposed to be here. And then this chlorine. Now, to name this, we are going to start. We have the functional group here. We have the single bond throughout, which is N. And then we have the OH, which is for alkanol. And then we have the halogens, that's for the haloalkanes. So this is a haloalkane, and also there is an alkanol attached to it. So between halogen, the single bond, and the OH, which one have priority over the other? The OH have priority. Therefore, this is my carbon number 1. Exactly. Among these 5 carbon in the main chain, this is my carbon number 1. Therefore, here is my carbon 1, 2, 3, 4, and 5. Remember, there is nothing like number from left to right or right to left. So if I twist this molecule in this form, it is still automatically showing that this is carbon 1, 2, 3, because I'm respecting the OH and not my left hand side or my right hand side. So in numbering the carbon atoms in the main chain, number from the end closer to the principal functional group, which is the OH. So remember that when you are facing someone, if your name is Isaiah, if you are facing someone, if you now back the person, your name will not change. So that's why teaching you to number from left to right is a wrong concept, and teaching you to number from right to left is a wrong concept. You can number from any direction. What determines your numbering is the position of the principal functional group. Therefore, for us to start naming this, at carbon number 1 there is only OH, and we have already pent because of the 5 carbon in the longest chain, 1, 2, 3, 4, 5. So that pent, and because of ANE, because of the single bond, we put A, but because of the OH, we remove the E that's supposed to be in pentane and put OL, and that is pentan 1-ol, because this OH is attached to carbon number 1, and this makes this primary alcohol or primary alkanol either. If it is attached here, I will say pentan 2-ol, but because it's attached here, I will say pentan 1-ol, or I can just say pentanol. Now, at carbon number 1, there is no other group apart from the main functional group. Hydrogen should not be recognized. Then here there is another atom, which is this green color of chlorine, and that's 2-chloro. So at carbon number 2, there is a chlorine. So the possible substance groups are, we have gotten 2-chloro. We now move to carbon number 3, which is here. At carbon number 3, there is no substance group, so we will not recognize that. Then at carbon number 4, there is another group that is not hydrogen, which is this CH3 over here. And that CH3 is methyl, because it's one carbon, we call it methyl. Therefore, we have 1, 2, 3, 4. And at that 4, we have a methyl. So this becomes 4-methyl. Then we move again to carbon number 5. At carbon number 5, we still have chlorine, and that is 5-chloro. Now, because we have chloro and chloro, the chloro should go first before methyl, irrespective of the 5 and 4. Alphabetical order for substance group C before M. And because we have 2C, we have to factorize and join them together. Therefore, what we have is 2,5-dichloro. I say di because we have 2 chlorine, 1, 2. How will you know? By mentioning 2 digits, you say di. If I say 253, I'll say try. If I say 111, I'll still say try. If I say 22, I'll say di. So the digits you mentioned determine. So 2,5-dichloro. Then we have 4-methyl. Yes, 2,5-dichloro. 4-methyl pentan-1-ol. Remember to join. Is one word. It's just a name of a compound, so don't need to separate it. Pentan-1-ol, or you can just say 2,4-dichloro, 4-methyl, 1-pentanol, or you can just say 2,5-dichloro, 4-methyl pentanol. And when they say pentanol without putting 2 or 3, it means that it is automatically 1. So this is the name of this particular compound here. This compound here, the name is this, and that is the structure I am holding here. Thanks for watching.
Much love, remain majestic.